what can you tell me about the A value? Who can tell me something about the A value? Is it positive or negative? Positive, right? Wait, did you say positive? No. No, it's negative. Why? Someone help her out. Why should I know that the A value is negative, Sierra? Because it's opening down, exactly. When something opens down, the A value is negative. So we know A is negative. What do we do with B? What's that? Right, negative B over 2A would give us the vertex. And so if I do that quickly, negative B over 2, and I know that A is a negative number, right? 2 times a negative number. What do you know about negative B over 2A? Should that full quantity be positive or negative? Positive, because it gives you the x-coordinate of your vertex. Negative B over 2A should be a positive number. So should B be positive or should B be negative in order to keep this whole thing positive? Right. B should stay positive because then the numerator would be a negative over a negative, which would make a positive. So B, that's a little bit of a multi-step thought process, but B should be positive. And C stands for the what? Y-intercept, which is here. Is that a positive or a negative? Positive. Again, I don't know if it's positive 1 or positive 2 or positive 3, but I know it's positive. I know negative B over 2A is supposed to be positive, so I had to think back as to what B would have to be, knowing that A was negative. So, based on those 3 pieces of information, think now about which one of these has to be true. Has to be true. Some of them might be true, might not be. Well, what has to be true? Give everyone a second and we'll to think about it. Based on these, which one of those has to be true? And we'll take a vote in about 30 seconds. Okay, on the count of 3, hold up your answer. 1, 2, 3. Good. I'm seeing mostly 3, and 3 is the correct answer. With the first 2, when you add 2 numbers together, to find out whether or not they're greater than 0 or less than 0, it kind of depends on the magnitude of the numbers, right? Unless they were both negatives and we were adding them together, then we would know it would be negative. And if they were both positives, but A and C is a combo of negative, positive, and A and B is a combo of negative and positive. So there's really no way to know. When you multiply, however, a negative times a positive will always be a negative, and a negative will always be less than 0. That's why that one was correct. And B times C is positive times positive, which will always be a positive, which is not ever less than 0. So 3 is correct. That is a Common Core question through and through. There's so much that goes into that. The basic facts that we learned this chapter are like A, B, and C, and deciding whether or not they're negative or positive, knowing what those values stand for and do for you, which is arguably on our flashcards. But you have to be able to read and interpret in order to get that right and understand what the heck they're even asking you. And that's where the Common Core requires that you're able to like apply basic facts as opposed to just knowing basic facts. Number 2 gives us the height of an object. For which of the following intervals of t is the object above a height of 350? So, a couple things here. The height they're telling you is 350. So I could throw that in there. And I'm just going to pretend this is an open response because any of these could be written as open response. If I solve this, I'll know exactly where this parabola is at 350. does this parabola open up or down? Down, because it's negative. So my parabola looks something like this, and I'm essentially looking for where it's exactly 350. So I'm going to be given some x coordinate, my first x coordinate, and then it'll be equal to 350 a second time. And so between which two values will this be above 350? So it'll be between my two answers. So I essentially have to solve that. And whatever the two numbers are will be the ones that show up. And I solve it by getting this thing equal to 0, and probably not going to be factorable with a 4.9 as your A. So you would just do the quadratic formula, which you have to know. I think you know it, although I'm not positive, and I should put it on a flashcard. So, 38. Quadratic formula. Who can tell it to me? Good, Haley's doing it. Good? Good. Now, that would be the algebraic way of doing it, is to subtract that 350 over. How could you do this on your calculator? Lucas? Plug what in? Okay, so if I go into my table right now, I'm looking at some crazy numbers. So he's saying just look for where the y is above 350. So somewhere around 7 seconds. And then it starts coming back down to somewhere after 10. So it looks like maybe 3, right? That's going to get you in the ballpark, because obviously you can't get your y coordinates to be exactly 350. How could I do it exactly? We got to start doing things like, because if this was an open response, how are you going to do that with your calculator? So here's my parabola. My window, the x coordinate is standing for time. So if I were to do like 0 to 10 seconds, right? Do you think the object would come back to the ground before 10 seconds? Hopefully. Maybe not. We might have to increase that. But the height, I could find the maximum height by doing my vertex, negative b over 2a and all of that stuff. Or I could just sort of guesstimate. It's starting at a height of 5. It's going up. I could plug in a random like 5 seconds and see how tall it is. Let's just say I did that and I got like 200 feet in the air. That might be way too much. But then graph it. Didn't quite go far enough in either direction because it never came back down. So I'm going to go to 20 seconds and a 400 height. So how could I find out where this is exactly above 350? Nobody? You guys love your table. I hate the table. Because if this was open response, the table's not helping you. Jack? Like second trace value? But that has you plug in your x coordinates. So what would you do? Because we know that our y coordinate is 350. Sierra? I could do the maximum. Left bound, right bound. But my question is, what are you going to get from that? Because I already know it's above 350 there. It's at 365. 8.5 seconds. So where is this section of time where it's 350 and higher? How am I going to find here and here? What? That table. Whoever got you in that table habit. I gotta, not that it's bad, it tells you stuff, but it doesn't give you exactness in a case like this. How about you graph a second line? 350. And then see where they cross, right? Second trace, intersect, scroll to the left. If I want that one first, enter, enter, enter. That'll give you 6.8 seconds on the nose. Yes? And then do it again, second trace, intersect, go over to the other intersection, enter, 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 and then it'll give you 10.3. So if you had to round to the nearest tenth and keep it exact, you can do that. Okay? Larger root, this would just be either, if you can factor it, tee it up, find your two answers, and take the larger one. If you can't, which just judging by these answer options, I'm pretty positive that nothing here is factorable. You have to do the quadratic formula, take your larger of the two answers. This one is a different format of the parabola, and it's asking you when it's decreasing. A sketch would be a good idea. What's the vertex of this? What do you think, Alexa? You don't know? Let me remind you what the format is. I just wrote it above. And HK should just throw the vertex right at you. What is it? What's in the H spot? And then the K is? Right. So 617, and I'm totally sketching, is somewhere up there in the first quadrant. Does this parabola open up or down, Jason? What'd you say? Good. So it is increasing initially, and then it's decreasing, and the interval is from an x-coordinate of 6 and beyond. It's decreasing the entire rest of the way. So it is decreasing when x is greater than 6. Good? Focus directrix. Write your own equation for the focus directrix information and see which one matches. If I jump, so that one is pretty straightforward, so I'm not going to talk too much more about that. On 6, center, point on the circle, find the radius. That's like question number 5, or whatever it was that Georgia asked about. Yeah, 5. They give you the center, they give you a point, draw a sketch, do the Pythagorean theorem. So that's pretty straightforward. Number 7's just, can you complete the square? Like we did on our homework quiz. 8, we've seen this question already, but this is a trickier version of focus directrix, but I actually taught to this type of question presentation this year. So I'll call it straightforward because I have taught this to you. They give you the directrix, and they don't give you the focus, and they don't give you the vertex, but they give you enough information. So I could solve for y by dividing by 12 and subtracting 3. So I should be able to say what the vertex is. And then once you have the vertex and the directrix, you can now find the focus based on the fact that the vertex is always halfway between. Number 9 doesn't really fit with this chapter, but I definitely can and do put like random review questions just sporadically in and amongst the tests. So usually what I'll do to pick those is I'll take something that was on a recent spiral, so it should be fairly fresh for you, and I'll throw it on the test. So this one doesn't fit really this chapter at all, but let's review it. The fourth root of 80. So sum of the perfect fourth power is 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. Do any of those go into 80? How many times? So fourth root of 16 times the fourth root of 5 will split up the 80. How should we split up x to the 9th? If we're taking the fourth root, we're looking for exponents to be divisible by what? 4. So how could you split up x to the 9th? X to the 8th, yes, and x to the 1st. And y to the 16th, 16 is already divisible by 4, so I don't need to split that up. I'll just leave it as the 4th root of y to the 16th. So now this, and this, I can actually take the 4th root of. 4th root of 16 is 2. 4th root of x to the 8th is what? X squared, good Owen. And the 4th root of y to the 16th is y to the 4th. So that covers those 3. And then I'm just stuck under a radical with 5x. The 5 and the x to the 1st couldn't be taken out, and there's your final answer. And I naturally showed it. 10 is pretty straightforward. They're saying, although I'll tell you what people normally do on this, and you can tell me where they screwed up and why this is wrong. They'll do 2 times 15 squared minus 13 times 15 plus 36. Why is that wrong? If someone does 2 times 15 squared minus 13 times 15 plus 36. Lucas. Right. When they do that, they're treating it as if this is what they were asking. Nobody asked you what f of 15 was, so we should not be plugging in a 15 for x. What they did was they told you when f of x equals 15, so this whole thing equals 15, and so what Lucas said was that they're technically giving you the y coordinate, and that is correct. And then you solve this. So subtract that 15 over. Hopefully it's factorable. If it's not, quadratic formula. In 11, if I'm solving this, distribute, right? I get 2x squared minus 50 equals 75x minus 3x cubed. How do you solve a polynomial equation like that? It's not a quadratic, is it? But we solve the same way as a quadratic in that we do start by getting it equal to 0. So I'm going to add my 3x cubed over and subtract my 75x. Get it all equal to 0. And there is no such thing as a cubic formula like there is a quadratic formula, so I have no choice but to factor by grouping, tee it up, solve. Which I'm not going to do because I would think that our factoring should be good by now. Another projectile. Determine algebraically when this will hit the ground. So, if they're asking you when, are they asking you for H or T? T, time, right? They're asking you when, they're asking for T. Which means they must give you H. Bella, what are they giving you for H? What? 8? They're saying when does the projectile reach 8 feet? No. No. When does the projectile hit the ground? What do you know about the height when it hits the ground? Right, so they're technically, and that's something you guys have to read into. Hitting the ground is when H is 0. So you're just doing 0 equals all of that and finding T. Don't just try to grab a number from the problem and set it equal to that. You have to read and interpret the question. Write an inequality and solve it algebraically to determine all the times at which that projectile is at or above 1,000. So here they are giving you an actual number straightforwardly. They're not saying hit the ground, so you have to assume it's 0. They're saying, when does it hit 1,000? So it says at or above. So when is this height expression going to be at or above 1,000? Negative 16t squared plus 340t plus 8 at or above 1,000. So essentially, just like everything else, we'll get it equal to 0. We'll solve it, and knowing that this opens down, whatever our two answers are, it's going to be at or above 1,000 in between those. So get it equal to 0, find your roots, and then your answer will be in between those two numbers. This one does say algebraically, so I have to do my quadratic formula or factoring. If I subtract 1,000, I could do the quadratic formula. Those are huge numbers. I could factor. Those are huge numbers. What could I do to resolve the huge number issue, Chloe? And what is the GCF? I was hoping so, but I just did 340, and that does not divide by 16. So maybe 4. Maybe 4 to start. What about 8? 340 divided by 8. Nope. So I think 4. $9.92 divided by 4. By the way, when you go to take out a GCF when you're solving, you don't actually write it out in front, right? You technically can divide both sides by 4 and just forget about it, which we'll say is what I did. Man, that's still not nice. So quadratic formula I would do. And show all that work. Get your two answers. And this will be between those. 13, straightforward. Focus directrix. Asks you to sketch it. So six, 8 will be our focus. Directrix, y equals 2. So take a moment. Figure out what the coordinates of your vertex would have to be. Vince, what do you think? Three, like here. 6, 4. 6, 4 is going to be 2 units away from this and 6 units away from that. We need to be halfway between 8 and 2. Average 8 and 2. The average of 8 and 2. Did you 6, 5? Then this is going to open up, and then you go ahead and you write the format, and then the last one is a system, which we could have a system of a line and a quadratic this chapter, or a line and a circle. This is a line and a circle. We're going to solve for x or y first, and then plug it into the other. That might be the exact same one that was on our notes. I'm not sure. So, study and review packet for homework. Test tomorrow.